In this video, we're going to develop a REST API using the PHP Slim microframework with data in a MySQL database. In doing so, you'll learn how to structure a typical application in Slim with controllers, middleware, and so on, and how to integrate third-party components easily into the framework. To follow along, you'll need a web server such as Apache, MySQL, and PHP. You can get all this in a single install with XAMPP. You also need to have Composer installed. To use the API, you'll need an API client such as Postman or HTTP. I'll be using the command line version of HTTP as it shows the results in the clearest manner. Let's get started. I've created a folder called Slim API to store the application code. This is currently empty. Let's start by installing the Slim framework. We'll do this on the command line using Composer, making sure we're in the folder I just created. This installs the Slim framework and its dependencies. Note that you can run terminal commands from within an IDE like Visual Studio Code, but to keep it clearer, I'm running them in the terminal directly. These packages are installed into the vendor folder, which is created automatically, along with the composer.json and composer.log files. Note how Slim doesn't create any folders or files by default. You're free to structure the application however you like. Before we can start using Slim, we need to install a package that implements PSR7. This is basically a package that contains classes to encapsulate an HTTP request and response. There are several to choose from, but Slim provides one, so let's go ahead and install that, again using Composer. Before we start to use these packages, first let's create a public folder. In a web application, it's important for security to keep publicly accessible files and other files separate. The public folder will be directly accessible by web browsers and API clients. All other application code goes outside this folder. Inside the public folder, let's create a new file called index.php. In here, let's add the PHP opening tag and enable strict type checking. Then we need to allow the class files we're going to use to be loaded automatically. As we're using Composer, we can do this by requiring Composer's autoloader. We'll use the dir constant with the dirname function to navigate to the parent folder of this script. Then, let's create an instance of the Slim application object. We'll do this by calling the static create method on the app factory class. This class is in the Slim factory namespace. So instead of prefixing this class with its namespace here, let's import it into the current namespace with a use statement. Then we need to add a root. That will be the code that runs in response to a request. So let's call the get method on the app object, with the first argument being the path in the URL that this will respond to. In this case, we'll respond to the root path. For the second argument, we'll pass a callback function. This function is passed request and response objects as arguments. As above, let's import these classes into the current namespace with use statements. Note how I'm using interfaces here for the type declarations, not a specific class. This allows us to use any implementation of these interfaces. Inside the callback function, the request object represents the HTTP request received by the web server, and the response object is what is sent back to the client. So let's write some content to the response body. First, we get an object that represents the response body with the getBody method. Then we'll call the write method on that, passing the string hello world. Every Slim app route must return a response object, so let's return that from this function. Finally, at the end of this script, let's run the application. To run this, one option is to use the built-in development server. So on the command line, from the root folder of the application code, let's run that on port 8080. We'll specify the public folder as the document root using the -t flag. For now, let's try this in a web browser. If we go to localhost port 8080, we see the hello world message. However, this web server is only designed for local development. To more closely replicate a live server, let's serve the application from a locally installed web server instead. I'm going to use Apache, but there are configuration instructions for other web servers in the official documentation. First, in the web server's virtual host configuration file, I'll add a new virtual host using slimapi.localhost as the host name. Make sure you set the document root to the public folder. We also need to specify allow override all in the directory section so that we can use htaccess configuration files. I do have a video that goes into this in more detail if you need it, and there's a link in the description. Don't forget, if you make changes to the web server configuration file, you need to restart the server. Now in the browser, if we go to slimapi.localhost, we see the Hello World message. This is basically all Slim is. You define a route and code that will run when that route is matched. The code has access to the request and has to return a response, which is what is sent back to the browser. Let's change this route path so that it responds to the first API endpoint we're going to develop, which will be /API/products. In the browser, if I add this to the URL, we get a 404 object not found error. This is because by default, the web server will look for folders and files based on this path. To fix this, we need to configure the web server to run the index.php script for all URLs. With Apache, we do this by creating a .htaccess file containing rewrite rules. So from the documentation, let's copy this code for an htaccess file that will do just that. Then in the public folder, we'll create a new file called .htaccess and paste in the copied code. Now in the browser, we see the Hello World message again. Now we've got this working, let's try making the same request with an API client. I'm using http on the command line as it's simple and shows the results clearly. So let's make an HTTP GET request to the same URL, and we see the response headers, followed by the response body. Note how the default content type is HTML. Next, let's return some JSON instead of HTML. First, let's create a variable containing a JSON encoded array. We'll hard-code the array data for now. Then, instead of writing the Hello World string to the body, we'll write the body variable. To set the content type header, we call the withHeader method on the response object, setting the content type header to the JSON media type. Now when we make the same request, we get the JSON content type header and the JSON content in the response body. Next, instead of returning hard-coded data, let's get the product data from the database. I've already created a simple database to demonstrate this with a product table and a couple of example records. The SQL to create this is in the source code for this video, and there's a link in the description. We'll connect to the database using PDO. So first, let's create a DSN variable containing the connection string with the host, database name and character set. Then we'll create a new PDO object, passing in this variable and the username and password for the database. We want any errors that occur to throw exceptions, so we'll specify the error mode as such. Then we'll use the query method to select all the records in the product table, followed by the fetchAll method on that PDO statement object to get the records as an associative array. Finally, instead of encoding the literal array, we'll encode the data variable instead. Let's try that again, and now we get the data from the database in the response body. If we only had one endpoint, then having the database connection code in here might be okay. However, as we're going to have more than one, we should extract this out to avoid repetition. So let's create a class to contain the database connection code. First, let's create a source folder in the project root and an app folder inside that. Note that the app folder starts with a capital letter, so we can take advantage of PSR4 autoloading. Inside that folder, let's create a new file called database.php. Again, the file name needs to start with a capital letter. In here, let's add the PHP opening tag, enable strict type checking, set the namespace to app, matching the name of the folder it's in, and add the class definition. Then let's add a public method called getConnection, which will return a PDO object. As we are inside a namespaced class, so we can use the PDO class without prefixing it with a backslash, we need to import it into the current namespace with a use statement. Then, back in the index script, let's cut these two statements where we're connecting to the database and paste them in the getConnection method in the database class. At the end of this method, we'll return the PDO variable. To check that this works, back in the index script, where we just cut the database code from, let's require the database class file. Then we can create a new object of that class and get a PDO object by calling the getConnection method. Let's make the request again, and it still works as before. Next, let's change this so we don't have to explicitly require this class file like this, so that it's required automatically just like the classes we're using above. We can do this using Composer. In the composer.json file, after the require section that lists the two packages that we've installed, let's add an autoload section. Inside that, a PSR4 section, and in here, we'll specify an empty string for the key and the source folder for the value. This means that the autoloader will automatically load classes from that folder. Then, back in the index file, let's remove this line where we're requiring the database class file. When we make the request with the API client, now we get an error, saying that the database class wasn't found. When we make changes to Composer's autoload configuration, we need to run the dump autoload command so that Composer will generate the required autoload code. Now when we make the API request, it works as before. Now we've extracted out the code that connects to the database, let's do the same for the code that retrieves the data. We'll do this with a repository class. So first, let's create a new folder inside the app folder called repositories. Then a new file inside here called productrepository.php. In here, we'll add the PHP opening tag, enable strict types, and add the namespace and class definition. Note that we're matching these to the folders and file names, so they'll be loaded automatically. Then let's add a new public method called getAll, which will return an array. Back in the index script, let's cut these three statements where we're using the database object to retrieve some data, and paste them into the getAll method in the product repository class. At the end of the method, instead of assigning the array to a variable, we'll just return it directly. So we can use the PDO class like this from within this namespaced class, we need to add a use statement to import it. We also need a database object in here. Rather than explicitly create one in here, let's pass one in as a dependency. So let's add the constructor method with an argument that's an object of the database class. We'll promote this to a private property using constructor property promotion. Let's also import the app database class into the current namespace with a use statement. Then, in the getAll method, we can call the getConnection method on the database property. Back in the index script, after we've created a new database object, let's create a new product repository object. We'll pass in the database object to the constructor. Then we can call the getAll method on that, assigning the return value to the data variable. Let's make the API request again, and it still works as before. So now in here, we're creating two objects, one of which is dependent on the other. As with autoloading, we can do this automatically, using a dependency injection container. The Slim framework supports any dependency injection container that implements PSR11, the PHP standard for containers. PHPDI is one such container, so let's use that. First, let's install PHPDI using Composer. In the index script, to use PHPDI, first let's import the container class with a use statement. Then, before we create the application object, let's create a new object of the container class. Then we'll call the static setContainer method on the AppFactory class, passing in the container object. This configures the application with the Dependency Injection container. This means that inside this root, we have access to this container as a property of the current object. So let's replace this code, where we're explicitly creating a new database object with the new keyword, with a call to the container. The container has a get method that will return an object of the supplied class. So we'll pass in the fully qualified class name of the database class using its class constant. When we run this, it still works as before. The container has created the database class automatically. What's more, the container can also resolve dependencies automatically. This works as we're injecting the database object into the product repository object using the constructor, and we're using type declarations. So instead of using the new keyword to create the product repository object, we'll use the container. As the database dependency will be created automatically, we can delete this line where we're creating the database object. When we run this, it still works as before. This will work for any level of dependencies, as long as we inject them using a class's constructor, and we include a type declaration. Here in the database class, although this class isn't dependent on any other classes, the database connection credentials are hard-coded inside the getConnection method. Instead of having these in here, let's pass these in using the constructor. So let's add the constructor method with 4 arguments: the host, name, username, and password. We'll promote these to private properties. Then, in the getConnection method, we'll use the values of these properties instead of the hard-coded values. If we run the code now, we get an error. The container can't create an object of the database class automatically, as it doesn't know what values to pass to the constructor. To fix this, we can tell the container how to create an object of this class by adding an explicit definition for this class to the container. Instead of doing that here in the index file, to keep this simpler, we'll do it in a separate file. So let's add a new folder to the project root called config, and inside there a new file called definitions.php. This isn't going to be a class that will be auto-loaded, so we don't need to start it with a capital letter. Note that you can call this folder and file whatever you like. Slim or PHPDI don't place any restrictions on that. Inside this file, we'll start with the PHP opening tag, followed by a use statement for the database class. Then we're going to return an array from this file containing the definitions. The key for each definition is the class name, and the value is an anonymous function that returns the object. In this case, we want to return a new database object, passing in the constructor arguments for the database connection credentials. I'll use named arguments to make sure we don't get them in the wrong order. Note that in production you'd store these elsewhere, like in a .env file. There's a link to a video on how to store PHP configuration settings in the description. Then, back in the index script, we can pass these definitions to the container. To do this, instead of creating an object of the DI container class, we create one of the container builder class. Let's also change the use statement to import that class. Then we call the addDefinitions method on this object, passing in the path to the definitions file we just added. To get the folder this file is in, we need to use something like this that we used for the path to the Autoload script. So we don't repeat ourselves, let's define a constant called AppRoot with this value. We can then use this constant in the Autoload require line, and also in the line we just added. Finally, to build the container, we call the build method after the addDefinitions one. When we run this, now the error has gone, and it works as expected. Next, let's add another endpoint, this time for requesting a single product record. So this will be the same URL, but with the ID of the product in the next segment. So after the existing route, let's add another one, again using the get method. For the ID, we'll insert a variable segment, which we do inside curly braces. As above, the callback function takes arguments for the request and response. To get the value of the variable from the URL, the third argument to the callback function is an array of arguments. Inside this method, let's get the value of the ID segment of the URL, which is in the args array with an index that matches the name we specified in the route path. For now, let's just print that out in the response body to see what it contains, and then return the response. If we make a request to the /API/products/123 URL, we get 123 printed out. Whatever we put in the third segment of this URL, we get as the ID, including a string with letters. To restrict this, we can add a regular expression to the root variable. We do this by putting a colon after the variable name, then the regular expression. In this case, we'll restrict it to a string of at least 1 digit. Now, if we make a request to that URL with an ID that isn't digits, we get a not found exception. If we change this to just digits, then it works. Getting the value of segments from the URL in an array like this is the default way of doing it in the Slim framework. There's an alternative way to do it, where each argument is passed individually to the callback function. To enable this, let's add a use statement to import the request_response_args class into the current namespace. Then, before we define the routes, we call the getRouteCollector method on the app object to get a route collector object. Then we call the setDefaultInvocationStrategy method on this, passing in a new object of the request_response_args class. Then, for the second route, where the third argument is an array, we can change this to just the ID. Note that this is a string, as all arguments that come from the URL are strings. Now we can remove the line inside the callback function where we're getting the ID from the array. The value of the ID variable will be assigned directly from the URL. When we run this, it works as before, getting the value of the numeric ID from the URL. Now we have the ID, we can retrieve the product record from the database with that ID. To do this, first let's add a method to the product repository class. We'll add a public method called getById with an integer argument for the ID. Inside this method, we'll create a variable containing the SQL string to select a product record with a constraint on the ID. We'll use a placeholder for the value of the ID to avoid SQL injection. Note that although this will only ever be an integer because we're using strict type checking, we don't strictly need to do this, but whenever I'm inserting a value into an SQL string, I always prefer to use prepared statements with named parameters so that I don't accidentally expose the code to an SQL injection attack. Then we'll get the database connection and create a prepared statement from the SQL. Then we'll bind the value of the ID argument to the placeholder as an integer and execute the statement. We'll return the results of executing this as an associative array. The fetch method will return an array if the record is found or false otherwise. So let's add an appropriate type hint to the method's return value. Back in the index script, now we can use this new method. So let's get a repository object from the container, then call the getById method on that object, passing in the ID. As this method requires an integer argument, we'll cast the string value to an integer. Then we can JSON encode the product data and write this to the body instead of the ID. Let's not forget to add the JSON media type to the response. Let's run this using a product ID that we know exists in the database, and we get the individual product record in the response body. If we make the same request with a product ID that doesn't exist though, we get false in the response body. Note also that the response code is 200. Instead of this, after we've called the getById method, let's check to see if the response is Boolean false. Slim includes some custom exception classes we can use for cases like this. In this case, the HTTP not found exception is the one we want. So inside the if block, let's throw a new exception of that class. We have to pass in the request, and let's pass in an optional message. When we run this, we get the exception as expected, including the custom message. The status code is still 200, however, when we should be setting this to 404, the status code for when a resource isn't found. The response is returned when the exception is thrown, so we can't manually set the response code on the response object, as this isn't returned. Instead, we can fix this using some middleware. In Slim, middleware can modify the incoming request before the request handler gets it, and modify the outgoing response after the request handler has output it. Slim includes some error middleware to handle errors. So before we define the routes, let's call the addErrorMiddleware method on the app object. The first argument toggles the display of error details, the second if errors are logged, and the third if error details are logged. Now when we run this, we do get the 404 status code, and we also get a full HTML document with the details of the error. As we're developing an API though, we don't want HTML to be output, rather we want JSON. To fix this, we'll get an instance of the error handler by calling the getDefaultErrorHandler method on the errorMiddleware object. Then we can call the forceContentType method on this, setting it to the JSON media type. Now when we run this, we get the correct content type, and the body is also output in JSON format. The code we just added sets the content type for errors. For the two routes we've already added, we're explicitly setting the content type in each one. We can remove this repetition with middleware too. Let's do this in a new class. So first, let's add a folder to the app folder called middleware, and a file inside that folder called addJSONResponseHeader.php. In here, we'll add the PHP opening tag, enable strict types, and add the namespace and class definition. In Slim, to create middleware in a class, we add the magic invoke method. This takes two arguments, one for the request and one for a request handler. This has to return a response object. Let's add some use statements to import these classes into the current namespace. Then, in the invoke method, as we want to add a header to the response, we'll call the handle method on the handler object, passing in the request. This will give us the response. Then we can return that, adding the JSON content type header. Back in the index script, before we enable this middleware, let's remove the code where we're manually adding this header in both routes we currently have. Let's just check the header is now back to the default for HTML, and it is. To add this middleware, first let's import it into the current namespace with a use statement. Then, before we add the routes, we call the add method on the app object, passing in a new instance of the middleware class. This will run this middleware for all the following routes. Now when we run it, the content type header is set to JSON. So we just added some middleware that modifies the response. Middleware can also modify the request. Let's look at an example of how we do that. In this route, we just added code to get the product record based on the ID in the route, throwing an exception if there isn't one. Let's move this to some middleware. In the app middleware folder, let's make a copy of the addJSONResponse header file and call it getProduct.php. In here, we'll change the class name accordingly. In the body of the method, we need the ID parameter from the route. To do that, we need to use the route context class. So first, let's import that into the current namespace. Then, in the invoke method, we can get a route context object by calling the fromRequest method on that class, passing in the current request. Then we can get a root object and the ID argument from the root. Then in the index, let's cut this code that uses the repository to get the product record, throwing an exception if it's not found. We'll paste it in the getProduct middleware. For this to work, we need a repository object. So let's add the constructor method with an argument of that class. Let's also add use statements for the product repository class and also the HTTP not found exception class. So now we can remove this line where we're getting a product repository object and use the property instead. We can also remove the namespace where we're throwing the HTTP not found exception. If the exception hasn't been thrown and the product variable doesn't contain false, we can pass it to the handler using the request. We do this using the withAttribute method, providing a key and value. Then, instead of assigning the response to a variable, let's just return it directly. We can also remove this line which is left over from when we copied the other middleware. Then, back in the index, at the point we just removed the code that gets the product, we can get this from the request, using the same key we used to save it in the middleware. To run the middleware we just added, we call add on this root directly, passing in the fully qualified class name of the middleware class. We need to use the class name and not an object as we did with the other middleware, so that the container will resolve any dependencies. Let's give that a try. If we request to see a record with an existing ID, we see it as before. If the ID doesn't exist, we get the 404 response. Note that the error is coming from the middleware. Now we have two roots defined in this script using callback functions. As we add root handlers to this script, it's only going to get longer and more complex. An alternative with Slim is to define the function separately inside a class. When doing this, we can either define a regular public method or implement the magic invoke method. Let's try the latter for the first root. First, let's add a folder to the app folder called controllers. Inside here, we'll create a new file called productindex.php. We'll add the PHP opening tag, enable strict type checking, and add the namespace and class definition. Then, let's add the public invoke method. As with the callback function, this method needs to accept request and response arguments and return a response. So first, let's copy these use statements where we're importing the request and response interfaces and paste them in the controller class. Then we can add the arguments to the method and the return type declaration. Then, back in the index page, let's cut the contents of the callback function and paste them in the controller method. The first line of this method uses the container to get an instance of the product repository class. However, we don't have access to the container inside this class. So instead, let's inject this dependency using the constructor. First, let's add a use statement to import the product repository class. Then, let's add the constructor method with an argument for the product repository, promoting it to a private property. Then, we can delete the line in the invoke method where we're getting a repository object, and on the next line, use the property instead. Back in the index file, instead of the callback function, we specify a string containing the fully qualified class name of the class we just added. By doing this, the container will be used automatically to create an instance of this class, so its dependencies will be resolved automatically. When we run this, it works as before. Using this technique means that you can only have one handler per class, as you can only have one invoke method. This is fine if you want to do it that way. Alternatively, you can have multiple methods per class if you use regular public methods. To see how this works, let's do this for the other route that we have defined, to retrieve an individual product. Let's start by making a copy of the product index class and calling it products. In here, let's change the class name accordingly. We'll also change the name of the invoke method to just show, delete the contents, and we'll add a string argument for the ID. This is so it matches the arguments of the callback function. Then let's cut the contents of that function and paste them in the show method. Then, back in the index, instead of the callback function, we specify a string with the controller class name, followed by a single colon and the name of the method. Let's give that a try. For an ID that exists, we see the record details as expected. For an ID that doesn't exist, we get the 404 response. Now though, the index script is much cleaner, and the code that responds to requests is nicely separated out into separate classes. Next, let's add functionality to allow us to create a new record. First, in the product's controller class, let's add a new public method called create, with arguments for the request and response that returns a response. The first thing we need to do in here is get the data from the request body. As request data in an API is typically sent as JSON, we need to decode this from the request body. The PSR7 standard doesn't support this format, but as this is a common requirement, the slim PSR7 implementation we're using provides some body parsing middleware to do just this. To add this, in the index script, we call the add body parsing middleware on the app object. Note that we do this before the error middleware is added, so that any errors that occur in the middleware are processed by the error handling middleware. Then, in the create method in the controller, we can get the parsed body contents by calling the getParsedBody method on the request. For now, let's just JSON encode this value, write it to the response body, and return the response. Then, back in the index script, we can create a route that will run this method. In a RESTful API, to create a new resource, we use the post method. So let's add the post route for the URL /API/products. To specify the controller method, instead of using the technique above, where we specify the class and a method separated by a single colon, an alternative is to specify an array, with a value for the class and one for the method. It doesn't matter which of these you use, they're equivalent. I prefer the single colon method as I think it looks a bit clearer, but it's up to you. Let's give that a try. If we make a post request to the /API/products URL, we get null returned in the response body. If I add some values, these get returned. Note that HTTP automatically formats the request data as JSON. If you're using Postman, you'll have to write JSON in the raw request body. Now that we have the data, we can insert it into the database. First, let's add a method to the product repository class. We'll add a new public method called create that has an array of data as an argument. In here, let's write the SQL to insert a new product record using named placeholders for the values. Then we'll connect to the database as above and prepare the statement. Then we can bind values to the placeholders. First the name, which is a string. Then the description. But as this can be null, first we'll check to see if it's empty. If so, we'll bind null, otherwise we'll bind the value as a string. Finally, we'll bind the size as an integer. Then we can execute the statement. As we're not supplying a value for the ID, this will be assigned automatically as it's an auto-increment column. So let's return the value of this ID, which we can get from the last insertID method. As this returns a string, we'll specify a string as the return type. Back in the create method in the controller, after we've got the contents of the request body, let's call the create method on the repository property, passing in this data. We'll get the ID of the created record from the return value. Then, instead of returning the JSON encoded request body, we'll return a message and include the ID of the newly inserted record. Finally, when creating a new resource, we want to send back a 201 status code with the response. Let's give that a try. If I send a post method to the product URL, including values for the name, description and size, we get the 201 response with the ID of the new record in the response body. If we make a GET request to get that record, we can see the data has been successfully inserted into the database. What happens though if we make a request to create a new record, but we omit the size, for example? We get a couple of errors, as there is no size element in the array of data, and in the database, the size column doesn't accept null values. Likewise, if we don't send any data at all, we get another error as the request body will be null, and the create method in the repository is expecting an array. So we need to validate this data before we insert it. Let's find a package to do this. There are many validation packages available. Let's go with Valitron as it's simple to use and has no dependencies. We'll install this on the command line using Composer. To use this in the controller, let's add a dependency for an object of the Valitron validator class. So we'll add a use statement, then an argument to the constructor for an object of that class. Next, inside the constructor, we'll call the mapFieldsRules method on the validator property to specify the validation rules. We'll make the name required, and the size required, and an integer with a minimum of 1. The format of these rules is specific to the Valitron package. Then, back in the create method, after we've got the contents of the request body, we'll use the withData method of the validator property to set this data in the validator. The validate method returns a Boolean value based on whether the data are valid or not. If not, let's set the response body to the JSON encoded validation error messages, which we can get from the errors method. Then we'll return the response with a 422 status code for unprocessable entity. Let's give that a try. If we request the endpoint with no data, we get the 422 response with the error messages in the response body. If I add some data, but not all of it is valid, we get the same response, but only with the error messages for those data that are invalid. If we send correct data, then the record is created as before. This is just a simple example of how to do validation using this package. Check out the Valitron documentation for full details of how to use it. Next, let's add functionality to update an existing resource. In the repository, as this is going to be similar to the create method, for the purposes of this example, let's keep it simple and copy the create method, renaming the copy to update. Then let's change the SQL so it updates a record instead of inserting one. We'll include a where clause for the product ID. We'll keep the existing code that prepares the statement and binds the values of the variables. We do need to bind an additional value though for the ID. So let's add an integer argument to this method for the ID. Then we can bind the value of that to the ID placeholder. At the end of the method, instead of returning the last insert ID, let's return the number of rows affected, which we can get by calling the rowCount method on the statement object. This returns an integer, so we'll change the return type declaration accordingly. Then in the products controller, again to keep it simple, let's make a copy of the create method and rename the copy to update. As with the show method, we need to add a string argument for the ID so we can identify the record being updated. After we've validated the data, instead of calling the create method, we'll call update, adding the arguments for the integer ID. We'll also change the name of the variable we're assigning the return value to rows. For the response, we'll change the message to product updated and return the number of rows that were updated. Finally, in this method, upon a successful update, we return a 200 status code. As this is the default, we can omit the withStatus call. Then in the index script, let's add a route that uses the patch method. We'll include the ID in the URL and run the update method in the products class. Let's also add the getProductMiddleware as we did with the show method. Let's give that a try. If we make a patch request to the update endpoint, but with an ID that doesn't exist, we get the 404 message. Note again how this is coming from the middleware. If we make a request with a valid ID but invalid data, then we get the 422 response with the validation messages. If we make a valid request, then we get a 200 response, and we can see that one row has been updated. If we request the details of that record, we see the updated data. Finally, let's add functionality to delete a resource. In the product repository class, let's add a new public method called delete with a string argument for the ID that returns an integer. We'll add the SQL to delete a record with a where clause on the ID. Then we'll get the database connection, create a prepared statement from the SQL, and bind the value of the ID to the placeholder. Then we'll execute it and return the number of rows affected. Then in the controller, let's add a public method called delete with arguments for the request, response, and the ID. In here, let's call the delete method on the repository object, passing in the ID and getting the number of rows affected. We'll create a JSON encoded message body with a message and the number of rows. We'll write that to the response body and return it. The status code to return when deleting a resource is 200, so we don't need to change it. Then in the index, let's add a delete route with a variable for the ID. We'll run the delete method in the controller, and we'll include the middleware to get the product based on the ID. Let's give that a try. If we send a delete request to the product with an ID of 1, we get the message that the resource was deleted. If we send the same request again, now we get a 404 response as that record no longer exists. We now have several endpoints that use the same URL for a single resource, but with different HTTP methods. Let's see what happens if we use a method that we haven't implemented for that URL, for example, post. We get a 405 method not allowed response, which also includes the methods we have implemented in the allow header. This is generated automatically by Slim. Now we have the routes we want defined in the index, let's clean this up a bit. First, let's add some use statements for the controller and middleware classes we're using. While we're here, we can also remove these two use statements for classes we're no longer using in this file. Then we can remove the namespaces from the controller classes and middleware. If we try running one of these, we see they still work as before. We can clean this up further by extracting out the common part of each route path. Each endpoint starts with an API segment, so we can group these routes together. To do this, we need the Slim route collector proxy class, so let's import that with a use statement. Then, before the first route, we call the group method on the app object, where the first argument is the common part of the URL, in this case /API. The second argument is a callback function whose argument is an object of the route collector proxy class. We'll end this call after the routes. Now, instead of adding the routes on the app object, we add them on the group object. We can also remove the API prefix from these routes. Again, these still work as before. In addition to common route segments, we can also group together routes that share middleware. For example, the show, update, and delete routes. To show this, first let's move the show route down so it's grouped with the others that require an ID. Then let's add a group around these routes with an empty string for the route path. As all these routes share the same middleware, we can add the middleware onto this group instead, and then remove it from each individual route. Again, these still work as before. Now the routing code, though, is much clearer. There's a link to all the source code shown in this video in the description, along with links to sites shown and relevant documentation. Please don't forget to like, comment and subscribe, and as always, thank you for watching.